We're going to conduct an independent samples t-test. Now this looks different than the paired samples t-test. Paired sample is all about comparing a related data set. Pre-post is usually the situation associated with that. But in an independent samples t-test, the samples are independent from one another. Generally, you have a comparison group and an intervention group. That's what we're going to be working with today. On my MSLQ data, I have a t-test in class. That's the data I'm going to be using today. And I'm going to be taking a look at Group 1 and Group 2, which is students who are in an aquatic science class and an advanced placement environmental science class, comparing their results on a self-efficacy scale of the MSLQ. Now, if you recall when we did the pair samples t-test, you would see Group 1 side by side with Group 2. It made it very easy for doing the frequencies. However, the independent samples is set up quite differently, where the group, you have to have a grouping data set. So it's not, this data is set up to do a t-test. However, it's not set up to run frequencies or descriptive data. So I have to set that up. I typically like to do this in the spreadsheet in advance before I move the data over to SPSS, so I have it all organized. You see, this is not perfect data. There are some blanks. That's okay. So what I do is I'm going to copy Group 1 here. I'm going to put it right here. And I'm going to do the same thing for Group 2. Now I can take the data, all 5 rows, blank in the middle, copy that out, and there we go, paste it into SPSS. Fantastic. So now I'm going to set up my variables. So the first column was the group, and I do know those values. I know that 1 is aquatic science, and I know that 2 is AP environmental. And then I also know the 2 is self-efficacy. And then we know there's nothing in row 3. And then we have the self-efficacy aquatic science. I'll abbreviate that, and self-efficacy AP environmental science. Great. So now we have our data labeled, set, and ready to go. We can run our descriptives, and our descriptives are done the same way each time. We go to Analyze, we go to Descriptives, click on Frequencies. I'm going to move these 2 over. Those are the 2 that I specifically set up. So we can do descriptives. I'll do the quartile, the mean, deviation, min, max, skew, and kurtosis. Run that. And there we go. So let's take a look what we have. We have a mean of 5.2 for the aquatic science and a mean of 4.7 for the AP environmental. Now the purpose here is to compare those 2 to one another. Are these numbers statistically similar, or are they statistically different from one another? We could also visualize this if we wanted to. Make a box and whisker. Not required, but certainly could do that. We know the self-efficacy scores are in that column, and we can separate them by group, and we can run that. So the question is this statistically similar to this? I don't know if it necessarily looks similar, but we'll have to do an analysis. We can certainly see that the top is the same. The medians are close. This one's a little higher, but this box seems to be sitting, the interquartile range box seems to be sitting a little higher. Okay, so these are just eyeballing things we're doing right now in descriptive statistics. We're guessing. We're not actually analyzing fully. To do the analysis, we're going to go to Analyze, Compare Means, Independent Samples, t-test. We're going to move over the grouping variable. And in this case, we have to define the groups. It's already done it for me. There's groups 1 and 2, so I'm just going to let that go. And then I'm going to move over the self-efficacy variable into the test variable, and we can run it. Now we can take a look at the results and see what we've got. So again, this is a means test. We're comparing the mean to the mean. Are they similar or are they different? So we can see here we had 74 individuals in the aquatic science group with a mean of 5.2 and 54 in the second group with a group of 4.7. And again, the question is 5.2 statistically similar or different from 4.7? Standard deviations are fairly close to each other. The first thing we have to do is we have to decide if these curves look statistically similar to one another to start with, because we can't be comparing apples and oranges. They have to look similar. So we do what's called the Levene's test for equality of variances. And again, as you might recall from previous, we are not looking for statistical difference. We're looking for statistical similarity. And if we look at the sig value, 5.94, that is not significant. So we pass the Levene's test because there's no statistically significant difference in the shapes of the curves between the two groups. Now we have to go to the t-test. Since we know the shapes of the curve look the same, the second question is, where do they line up on the number line? Does that look similar or does that look different? So we get our, when we pass the Levene's test, we have equal variances assumed, which we have. And then we come into our t-test results. So there's our t-value, 2.295 or 2.30. The test statistic t. There are 126 degrees of freedom. And then because I don't go directional, I would go with the two-tailed test. And I can see the two-tailed test. It's got a value of 0.023. Again, p is less than 0.05 in this case, so we know there is a statistical difference between the groups. So the group is different. The groups are different from one another. How are they different? Go back to the means. This mean is different than this mean, which means this mean is bigger than this mean. So aquatic science students are showing higher self-efficacy, statistically significant higher self-efficacy than AP environmental science students are. We can take a look at our effect size on the co-ND. We look at the point estimate. We can see on the point estimate 0.41. That's still in the small range. From a practical significance point, it's not very impactful, but there is impact associated with it. And next we'll take a look at how this looks in the template. So let's take a look at the completed template for the hypothesis testing. So state the research question. So I say, is there a statistical difference in self-efficacy between students in an aquatic science program compared to students in an advanced placement environmental science program? So we're looking for difference. What are we looking for a difference in? Self-efficacy between students in the aquatic science compared to students in the AP environmental science. The program in this case, level 1, aquatic science, level 2, advanced placement, is the independent variable, and self-efficacy becomes the dependent variable. State the hypothesis. Again, we always state null, assuming there is no change. So there will be no statistically significant difference in self-efficacy between the two groups. The alternative is there will be a statistically significant. And again, that is written as a two-tailed example with no directionality to it. We're just saying there's going to be a difference. We don't say where the difference is going to be, or we don't predict in advance. That would be a better way to say it, where it shall be. We set the criteria for rejecting. That's P is 0.05, as it is fairly standard in educational research. Then we compute the test statistics. And in this case, we have the independent samples only. We do the Levene's test, which I did here. I recorded those data from the Levene's test. The F of 126 equals 0.29, which is greater than 0.05. The p-value, not this value itself. The p-value was, in this case, 0.594. So that's way bigger than 0.05. And then we did the t-test. T-test value, the test statistic is there. And the p-value in this case was 0.02, which is also, this one is less than 0.5, so that shows there's a difference. So we reject the null, accept the alternative, and then we write it up with the additional information. There was a statistically difference, significant, p less than 0.5 difference. There's the t-test results. Again, that's just the test statistic calculations. And then we're comparing means, 5.23, 4.74. We report the confidence interval off the table, and we determine the effect size, which was 0.41, which falls into the small range again. The ranges for effect, 0.2, 0.5, 0.8. And that is the way you complete the template for an independent samples t-test.